The geothermal areas of Yellowstone include several geyser basins in Yellowstone National Park as well as other geothermal features such as hot springs, mudpots, and fumaroles. The number of thermal features in Yellowstone is estimated at 10,000. A study that was completed in 2011 found that a total of 1283 geysers have erupted in Yellowstone, 465 of which are active during an average year. These are distributed among 9 geyser basins, with a few geysers found in smaller thermal areas throughout the park. The number of geysers in each geyser basin are as follows: Upper Geyser Basin, Midway Geyser Basin, Lower Geyser Basin, Norris Geyser Basin, West Thumb Geyser Basin, Gibbon Geyser Basin, Lone Star Geyser Basin, Shoshoni Geyser Basin, Heart Lake Geyser Basin. Other areas. Although famous large geysers like Old Faithful are part of the total, most of Yellowstone's geysers are small, erupting to only a foot or two. The hydrothermal system that supplies the geysers with hot water sits within an ancient active caldera. Many of the thermal features in Yellowstone build up sinter, geyserite, or travertine deposits around and within them. The various geyser basins are located where rainwater and snow melt can percolate into the ground, get indirectly superheated by the underlying Yellowstone hotspot, and then erupt at the surface as geysers, hot springs, and fumaroles. Thus, flat-bottomed valleys between ancient lava flows and glacial moraines are where most of the large geothermal areas are located. Smaller geothermal areas can be found where fault lines reach the surface, in places along the circular fracture zone around the caldera, and at the base of slopes that collect excess groundwater. Due to the Yellowstone Plateau's high elevation, the average boiling temperature at Yellowstone's geyser basins is 199 degrees Fahrenheit. When properly confined and close to the surface, it can periodically release some of the built-up pressure in eruptions of hot water and steam that can reach up to 390 feet into the air. Water erupting from Yellowstone's geysers is superheated above the boiling point to an average of 204 degrees Fahrenheit as it leaves the vent. The water cools significantly while airborne and is no longer scalding hot by the time it strikes the ground. Nearby boardwalks, or even spectators. Because of the high temperatures of the water in the features, it is important that spectators remain on the boardwalks and designated trails. Several deaths have occurred in the park as a result of falls into hot springs. Prehistoric Native American artifacts have been found at Mammoth Hot Springs and other geothermal areas in Yellowstone. Some accounts state that the early people used hot water from the geothermal features for bathing and cooking. In the 19th century, Father Pierre-Jean de Smet reported that natives he interviewed thought that geyser eruptions were the result of combat between the infernal spirits. The Lewis and Clark expedition traveled north of the Yellowstone area in 1806. Local natives that they came upon seldom dared to enter what we now know as the caldera because of frequent loud noises that sounded like thunder and the belief that the spirits that possessed the area did not like human intrusion into the realm. The first white man known to travel into the caldera and see the geothermal features was John Colter, who had left the Lewis and Clark expedition. He described what he saw as hot spring brimstone. Beaver trapper Joseph Meek recounted in 1830 that the steam rising from the various geyser basins reminded him of smoke coming from industrial smokestacks on a cold winter morning in Pittsburgh, Pennsylvania. In the 1850s, famed trapper Jim Bridger called it the place where hell bubbled up. Types of features found in the park. The heat that drives geothermal activity in the Yellowstone area comes from brine that is 1.5 to 3 miles below the surface. This is actually below the solid volcanic rock and sediment that extends to a depth of 3,000 to 6,000 feet and is inside the hot but mostly solid part of the pluton that contains Yellowstone's magma chamber. At that depth, the brine is superheated to temperatures that exceed 400 degrees Fahrenheit or 205 degrees Celsius, but is able to remain a liquid because it is under great pressure. Convection of the churning brine and conduction from surrounding rock transfers heat to an overlaying layer of fresh groundwater. Movement of the two liquids is facilitated by the highly fractured and porous nature of the rocks under the Yellowstone Plateau. Some silica is dissolved from the fractured rhyolite into the hot water as it travels through the fractured rock. Part of this hard mineral is later redeposited on the walls of the cracks and fissures to make a nearly pressure-tight system. Silica precipitates at the surface to form either geyserite of sinter, creating the massive geyser cones, the scalloped edges of hot springs, and the seemingly barren landscape of geyser basins. There are at least 5 types of geothermal features found at Yellowstone. Fumaroles. Fumaroles of steam vents are the hottest hydrothermal features in the park. They have so little water that it all flashes into steam before reaching the surface. At places like Roaring Mountain, the result is loud hissing of steam and gases. Geysers. Geysers such as Old Faithful are a type of geothermal feature that periodically erupts, scalding hot water. Increased pressure exerted by the enormous weight of the overlying rock and water prevents deeper water from boiling. As the hot water rises, it is under less pressure and steam bubbles form. They, in turn, expand on their ascent until the bubbles are too big and numerous to pass freely through constrictions. At a critical point, the confined bubbles actually lift the water above, causing the geyser to splash or overflow. This decreases the pressure of the system and violent boiling results. Large quantities of water flash into tremendous amounts of steam that force a jet of water out of the vent. An eruption begins. Water is expelled faster than the geyser's recharge rate, gradually decreasing the system's pressure and eventually ending the eruption. Hot springs. Hot springs such as Grand Prismatic Spring are the most common hydrothermal features in the park. The plumbing has no constrictions. Superheated water cools as it reaches the surface, sinks, and is replaced by hotter water from below. This circulation, called convection, prevents water from reaching the temperature needed to set off an eruption. Many hot springs give rise to streams of heated water. Mudpots such as fountain paint pots are acidic hot springs with a limited water supply. Some microorganisms use hydrogen sulfide, which rises from deep within the earth, as an energy source. They convert the gas into sulfuric acid, which breaks down rock into clay. Travertine Terraces. Travertine Terraces found at Mammoth Hot Springs are formed from limestone. Thermal waters rise through the limestone, carrying higher amounts of dissolved carbonate. Carbon dioxide is released at the surface and calcium carbonate deposited as travertine, the chalky white rock of the terraces. These features constantly and quickly change due to the rapid rate of deposition. Giza Basins. Norris Geyser Basin. The Norris Geyser Basin, 44.72861 degrees north, 110.70444 degrees west, 44.72861 minus 110.70444, is the hottest geyser basin in the park and is located near the northwest edge of Yellowstone caldera near Norris Junction and on the intersection of 3 major faults. faults. The Norris-Mammoth Corridor is a fault that runs from Norris north through Mammoth to the Gardner, Montana area. The Hebgen Lake Fault runs from northwest of West Yellowstone, Montana, to Norris. This fault experienced an earthquake in 1959 that measured 7.4 on the Richter scale. Norris-Geyser Basin is so hot and dynamic because these two faults intersect with the ring fracture zone that resulted from the creation of the Yellowstone caldera of 640,000 years ago. The basin consists of three main areas: Porcelain Basin, Back Basin, and 100 Springs Plain. Unlike most of other geyser basins in the park, the waters from Norris are acidic rather than alkaline. The difference in pH allows for a different class of bacterial thermophiles to live at Norris, creating different color patterns in and around the Norris Basin waters. The ragged hills that lie between Back Basin and 100 Springs Plain of thermally altered glacial cames. As glaciers receded, the underlying thermal features began to express themselves once again, melting remnants of the ice and causing masses of debris to be dumped. These debris piles were then altered by steam and hot water flowing through them. Madison lies within the eroded stream channels cut through lava flows formed after the caldera eruption. The Gibbon Falls lies on the caldera boundary, as does Virginia Cascades. The tallest active geyser in the world is Steamboat Grazer, and it is located in Norris Basin. Unlike the slightly smaller but much more famous Old Faithful geyser located in Upper Geyser Basin, Steamboat has an erratic and lengthy timetable between major eruptions. During major eruptions, which may be separated by intervals of more than a year, Steamboat erupts over 300 feet into the air. Steamboat does not lie dormant between eruptions, instead displaying minor eruptions of approximately 40 feet. Norris-Geyser Basin periodically undergoes a large-scale, basin-wide thermal disturbance lasting a few weeks. Water levels fluctuate, and temperatures, pH, colors, and eruptive patterns change throughout the basin. During a disturbance in 1985, Porkchop Geyser continually jetted steam and water. In 1989, the same geyser apparently clogged with silica and blew up, throwing rocks more than 200 feet. In 2003, a park ranger observed it bubbling heavily, the first such activity seen since 1991. Activity increased dramatically in mid-2003. Because of high ground temperatures and new features beside the trail, much of Back Basin was closed until October. In 2004, the boardwalk was routed around the dangerous area and now leads behind Porkchop Geyser. North of Norris, Roaring Mountain is a large, acidic hydrothermal area with many fumaroles. In the late 19th and early 20th centuries, the number, size, and power of the fumaroles were much greater than today. The fumaroles are most easily seen in the cooler, low-light conditions of morning and evening. Artists' Paint Pots is a small hydrothermal area south of Norris Junction that includes colorful hot springs and two large mud pots. Monument Geyser Basin. The Monument Geyser Basin, 44.68 for 17 degrees north, 110.75389 degrees west, 44.68 for 17 minus 110.75389 has no active geysers, but its monuments are siliceous sinter deposits similar to the siliceous spires discovered on the floor of Yellowstone Lake. Scientists hypothesize that this basin's structures formed from a hot water system in a glacially dammed lake during the waning stages of the Spindale glaciation. The basin is on a ridge reached by a very steep 1-mile trail south of artists' paint pots. Upper Geyser Basin. Media related to Upper Geyser Basin at Wikimedia Commons. South of Norris along the rim of the caldera is the Upper Geyser Basin, 44.4644 degrees north, 110.82917 degrees west, 44.46444 minus 110.82917, which has the highest concentration of geothermal features in the park. This complement of features includes the most famous geyser in the park, Old Faithful Geyser, as well as 4 other predictable large geysers. One of these large geysers in the area is Castle Giza, which is about 1,400 feet northwest of Old Faithful. Castle Giza has an interval of approximately 13 hours between major eruptions, but is unpredictable after minor eruptions. The other 3 predictable geysers are Grand Geyser, Daisy Geyser, and Riverside Geyser. Biscuit Basin and Black Sand Basin are also within the boundaries of Upper Geyser Basin. The hills surrounding Old Faithful and the Upper Geyser Basin are reminders of Quaternary rhyolitic lava flows. These flows, occurring long after the catastrophic eruption of 640,000 years ago, flowed across the landscape like stiff mounds of bread dough due to the high silica content. Evidence of glacial activity is common, and it is one of the keys that allows geysers to exist. Glacial deposits underlie the geyser basins, providing storage areas for the water used in eruptions. Many landforms, such as Porcupine Hills north of Fountain Flats, are made up of glacial gravel and are reminders that 70,000 to 14,000 years ago, this area was buried under ice. Signs of the forces of erosion can be seen everywhere, from runoff channels carved across the center in the Giza basins to the drainage created by the Firehole River. Mountain building is evident on the drive south of Old Faithful, toward Craig Pass. Here the Rocky Mountains reach a height of 8,262 feet, dividing the country into 2 distinct watersheds. Midway Geyser Basin. Media related to Midway Geyser Basin at Wikimedia Commons. Midway Geyser Basin, 44.51778 degrees north, 110.83222 degrees west, 44.51778 minus 110.83222 is much smaller than the other basins found alongside the Firehole River. Despite its small size, it contains 2 large features: the 200 by 300 foot wide Excelsior Geyser, which pours over 4,000 U.S. gallons per minute into the Firehole River, the largest hot spring in Yellowstone. The 370 foot wide and 121 foot deep head prismatic spring is also found here. Lower Geyser Basin. Media related to Lower Geyser Basin at Wikimedia Commons. Further north is the Lower Geyser Basin, 44.54944 degrees north, 110.83583 degrees west, 44.54944 minus 110.83583, which has a much less concentrated set of geothermal features, including fountain paint pots. Fountain paint pots are mud pots, that is, a hot spring that contains boiling mud instead of water. The mud is produced by a higher acidity in the water, which enables the spring to dissolve surrounding minerals to create an opaque, usually gray, mud. Also found in this basin is Great Fountain Geyser, whose eruptions reach 100 to 200 feet in the air, while waves of water cascade down its center terraces. West Thumb Giza Basin. Media related to West Thumb Giza Basin at Wikimedia Commons. The West Thumb Giza Basin, 44.41861 degrees north, 110.57306 degrees west, 44.41861 minus 110.57306, including Potts Basin to the north, is the largest geyser basin on the shores of Yellowstone Lake. The heat source of the thermal features in this location is thought to be relatively close to the surface, only 10,000 feet down. West Thumb is about the same size as another famous volcanic caldera, Crater Lake in Oregon, but much smaller than the Great Yellowstone Caldera, which last erupted about 640,000 years ago. It is interesting to note that West Thumb is a caldera within a caldera. West Thumb was created approximately 162,000 years ago when a magma chamber bulged up under the surface of the Earth and subsequently cracked it along ring fracture zones. This in turn released the enclosed magma as lava and caused the surface above the emptied magma chamber to collapse. Water later filled the collapsed area of the caldera, forming an extension of Yellowstone Lake. This created the source of heat and water that feed the West Thumb Giza Basin today. The thermal features at West Thumb are not only found on the lake shore, but extend under the surface of the lake as well. Several underwater hydrothermal features were discovered in the early 1990s and can be seen as slick spots or slight bulges in the summer. During the winter, the underwater thermal features are visible as melt holes in the icy surface of the lake. The surrounding ice can reach 3 feet in thickness. Perhaps the most famous hydrothermal feature at West Thumb is a geyser on the lakeshore known as Fishing Cone. Walter Trumbull of the 1870 Washburn-Langford expedition described a unique event while a man was fishing adjacent to the cone. Quote, "In swinging a trout ashore, it accidentally got off the hook and fell into the spring. For a moment it darted about with wonderful rapidity as if seeking an outlet. Then it came to the top, dead, and literally boiled." Fishing Cone erupted frequently to the height of 40 feet in 1919 and to lesser heights in 1939. One fisherman was badly burned in Fishing Cone in 1921. Fishing at the Giza is now prohibited. Early visitors would arrive at West Thumb via stagecoach from the Old Faithful area. They had a choice of continuing on the stagecoach or boarding the steamship Zilla to continue the journey by water to Lake Hotel. The boat dock was located near the south end of the Giza Basin near Lakeside Spring. Backcountry Giza Basins. Media related to Gibbon Giza Basin at Wikimedia Commons. Media related to Heart Lake Giza Basin at Wikimedia Commons. Media related to Lone Star Giza Basin at Wikimedia Commons. Media related to Shoshoni Giza Basin at Wikimedia Commons. The Gibbon, 44.6994 degrees north, 110.74278 degrees west, 44.69944 minus 110.74278. Heart Lake, 44.3000 degrees north, 110.51556 degrees west, 44.3000 minus 110.51556. Lone Star, 44.41389 degrees north, 110.81778 degrees west, 44.41389 minus 110.81778. And Shoshoni Giza Basins, 44.3544 degrees north, 110.79917 degrees west, 44.35444 minus 110.79917 are located away from the heavily traveled portions of the park. Some require several miles of off-trail hiking to reach. These areas also generally lack the boardwalks and other safety features of the developed areas. As falling into geothermal features can be fatal, it is usually advisable to visit these areas with an experienced guide, or at the very least, travelers need to ensure they remain on well-marked trails. Lying in the Snake River watershed east of Lewis Lake and south of Yellowstone Lake, Hart Lake was named sometime before 1871 for hart honey, a hunter. Other explorers in the region incorrectly assumed that the lake's name was spelled Hart because of its shape. The Hart Lake Giza Basin begins a couple miles from the lake and descends along Witch Creek to the lake shore. 5 groups of hydrothermal features comprise the basin, and all of them contain geysers, although some are dormant. The Shoshoni Giza Basin, reached by hiking or by boat, contains one of the highest concentrations of geysers in the world, more than 80 in an area 1,600 by 800 feet. Hot springs and mudpots dot the landscape between the Giza Basin and Shoshoni Lake. Hot Springs Basin is located 15 miles north-northeast of Fishing Bridge and has one of Yellowstone's largest collections of hot springs and fumaroles. The geothermal features that release large amounts of sulfur. This makes water from the springs so acidic that it has dissolved holes in the pants of people who sit on wet ground and causes mounds of sulfur 3 feet high to develop around fumaroles. The very hot acidic water and steam have also created voids in the ground that are only covered by a thin crust. Mammoth Hot Springs. See Mammoth Hot Springs. Mud volcano and sulfur cauldron. Media related to Hayden Valley geothermal features at Wikimedia Commons. The thermal features at Mud volcano and sulfur cauldron, 44.62472 degrees north, 110.43417 degrees west, 44.62472 minus 110.43417 are primarily mudpots and fumaroles because the area is situated on a perched water system with little water available. Fumaroles or steam vents occur when the groundwater boils away faster than it can be recharged. Also, the vapors are rich in sulfuric acid that leaches the rock, breaking it down into clay. Because no water washes away the acid or leached rock, it remains as sticky clay to form a mudpot. Hydrogen sulfide gas is present deep in the earth at Mud volcano. This gas combines with water and the sulfur is metabolized by cyanobacteria. A solution of sulfuric acid is formed that dissolves the surface soils to create pools and cones of clay and mud. Along with hydrogen sulfide, steam, carbon dioxide, and other gases explode through the layers of mud. A series of shallow earthquakes associated with the volcanic activity in Yellowstone struck this area in 1978. Soil temperatures increased to nearly 200 degrees Fahrenheit. The slope between Sising Basin and Mud Geyser, once covered with green grass and trees, became a barren landscape of fallen trees known as the Cooking Hillside. Trail maps. Video.